So, hi, Nikolai. I think the first time in the history of Airhacks FM, the first name is pronounced right or perfect, right?
Yeah, that was great. Yes.
Oh, perfect, because it's easy. So, what was your first computer?
My first computer was an Amiga 500.
Oh.
Well, when was that? Oh my, I can't tell. I think.
Okay.
I was too young. I didn't think back then. You know, time was endless, so I didn't put a pin into that. But I would guess I must have been around 10, maybe. I'm not sure.
Mm-hmm. But time is endless. This is true. As I remember, as a child, I mean, 1 year is eternity. So it is really
exactly.
And now the time flies. So you were 10 or around 10, right? And you get Amiga 500. Yeah. Amiga 500 was a dream machine for me. I always wanted to have one. This was like an alien machine. But what you did with it? What was your first action on the Amiga?
Yeah, that's actually really interesting because so here's the thing, right? I didn't know anything. My family neither. They bought me the thing because, my other kids had like a Commodore C64, and I was kind of like whining, I want to have something like that as well. And my dad scraped some money together and got us that thing. Well, we didn't know anything about. And I remember that, you would put in discs, to play your games. Mm-hmm. But when you forgot that, or when it was broke, it would boot into this weird blue environment. I didn't know what it was. And like it took me years to figure out that, I mean, even back then I didn't know it was an operating system. I had no idea, but I figured out, I can do stuff here. Like I can create files, and I created like a small table where my dad and I put some of his financial information. That was one of the things we did with the Amiga, but mostly I just play computer games.
Okay.
And I was really not an early programmer or anything at all. I was just gaming.
Okay, but regarding the blue screen, what you mentioned, was Amiga like C64 that it booted into the Visual Basic basic environment, or was it an operating system already?
Yeah, it's more like an operating system. Like it's really hard to recollect because back then I didn't understand it at all. But I think it's a kind of an operating system, very minimal one, of course. But so I think you already could do stuff with the mouse. And, we could. I remember back then when I wrote files. I didn't understand shift, so when I wanted to have a capital letter, I would hit caps lock, type the one letter, and then hit caps lock again.
Oh yeah, of course, right.
Yeah, exactly, of course.
But actually, the caps lock key is absolutely pointless, right? If you think about this.
But why? How do you yell on the internet, Adam? Do you keep holding down shift is so hard? Yelling with caps lock is much easier.
Yeah, you're right. So this is your Twitter key, right?
Yeah, exactly.
Okay, cool. Hey,
it's the angry Twitter key.
Yeah. What games you enjoyed on Amiga? You remember?
Oh boy, yeah, that was a long time ago though. So
you are not that old.
Recently, one of the games got a remake, and I watched, but I don't know what it was. I don't know what the name is now or back then. But I watched some YouTube video, and somebody said like, "Oh, this is a game I played." And I was like, "Wait, no, feels familiar." And it said, by the way, that used to be like an old Amiga or whatever game. Okay. I think it wasn't exclusive. I think it was Carrier Command.
Okay.
I played Settlers.
Okay.
Like there's a German board game, right? And there was a computer game variant of that. Oh boy, like back in the days when you had to click like each thing individually, I played, I think, Dune, right? The strategy game.
Yeah.
Was that Amiga?
No idea. I never had an Amiga, but I was just I know some games because I was also C64 fan, but I had actually only ZX Spectrum. So, but I really admired Amiga. So
yeah, it was really nice to have one. Oh, by the way, I got busted for illegal file sharing, basically.
Oh,
because back then you would go to the flea market. Yeah. And there would be this stand offering games, right? Just like copied games, and that's like the way I got games. I had no idea that anything was amiss. I was like, well, that's where I buy them, right? Where else would I buy them?
Yeah.
So, and then it's easy to copy discs. Yeah. And I had a couple good games. So I was like, yeah, well, I'm an enterprising small kid. My parents next go to the flea market to sell some stuff off I'm just going to tag along. And so I brought a couple of discs with me and I sold them. And then a couple came up and they were like, oh, that's great. We want to buy this game. Oh, cool. Yeah, sure. Oh, but sometimes when you buy these games, they don't actually work at home. I was like, yeah, I know. That's the actual problem. So like, but how can we be sure? maybe we can contact you. I was like, yeah, sure, no problem. Like, if it's a problem, I'll give you back your, I don't know, I think they paid like 1 or 2 marks per discs, which is like half of that in euros. So 50 cent, maybe a euro for a disc. And to me as a kid, that was actual money, right? That was pretty cool. Like, I got home after that with like $20. That's pretty cool.
Yeah.
And so then we got a letter, a cease and desist letter from the company running the game that I sold them.
Oh.
So they were working for the company collecting addresses. And I guess nobody on the flea market gave them an address because nobody's stupid enough to do that.
Okay.
12-year-olds.
What happened to you then?
Oh, nothing. They just wrote a letter like, you can't do this. If you keep doing this, we're going to sue you. So please stop. It was a classic cease and desist.
This was your first enterprise, and this is how you end up working for Oracle, right? This was...
Yeah, exactly. I thought, like, you know what? It's time for me to send out these letters.
Yeah,
Where
exactly.
can I do that?
Exactly.
How can I be the mean guy kicking other people in the
Now this is on your very first slide, right? This is the on your every presentation, you know. Never copy games.
Yeah. So, but my mom was really scared. I mean, I was like, because it's an actual letter from a lawyer.
Sure.
And I was like, I don't know what this is about. Oh, so this is not okay. Okay, shit. Okay, so we better stop doing it then. And so we stopped, and that's that.
Okay. What was your first, or what is your first line of code, or why you start hacking something, on the Amiga?
I didn't at all. Like back then, I had no idea what anything is.
Okay.
I was not like. I get that's actually a bit of a shame because I think if I would have known that that's a thing that you can do, I might have had interest in it. Okay. I don't know. I mean, the other side of things is that like if you're just coding just for itself, now that's fun to me because now I know I enjoy coding. So when I find like a new programming language, I just go online and do some stupid coding puzzles just to try out TypeScript maybe, right?
Yeah.
So now I would just do random coding, but back then I guess. Like, even if somebody would have showed me that I can do this, I would be like, okay, but what can I do with it? And probably not much. So back then I didn't have any questions. The first lines of code I wrote was in school, actually. High school. It was pretty late. I think it was 10th grade. So I would have been around 16.
Okay.
It was Turbo Pascal.
Okay.
And so there's a German called Hello Nicky, which is like hello, obviously, and then Nicky. So it's a simplified. In the end, I think it's just a library. Mm-hmm. It's a simplified way to learn the language. You're steering a robot through a labyrinth, right? So it's a 2D top-down vision of a labyrinth. It has like walls and pathways. Mm-hmm. And you can just go in each of the 4 cardinal directions, and you can check whether there's a wall in front of you. Mm-hmm. And then you can use that to learn, like go 5 steps ahead, and then do an if check if there's a wall, and if there is, go left or right, or write a loop that just goes to, stuff like that. So that's how we learn programming. So it was not actually Hello World, but it was kind of similar. So that's my first program experience. And so we then programmed in Turbo Pascal for 2.5 years. And then towards the end of the 13th grade, the teacher introduced us to Java.
Wow.
So that was actually really ahead of our time. That was 2000, 2001 maybe?
Okay.
If I got my numbers right, not entirely sure. Somewhere around that time.
So after 9/11, cool. You know it?
Was it? It must have. No. It must have been before.
Okay.
No, I graduated. Well, let me think. Okay, so I'm born in 1983, and I graduated 2002. But it wasn't actually the last year of school. I think it was the second to last year. So I think it was like early 2001 probably.
Okay.
Started with
this was very, very early for school, I would say.
Yeah, really, it was. She was fresh from university, so maybe that was the way she took. But the interesting bit about this was, I don't think she fully understood what all of this was about, and we surely didn't. Because we're like, okay, so we've been programming imperatively in Turbo Pascal, like these small toy problems, right?
Yeah.
For kids. And, a little bit more stuff. We had like we wrote a small chat client because of the Windows API, you can send messages over the network, right? So, but very, very rough, everything text-based. Not a lot of code. And then somebody comes along and does like the full Java applet stuff. Like, here's classes, and here's fields, and here's getters, and all of that. And you're like, why is this so complicated? Why do I have to do all of this? I just want to get a file.
Yeah.
Write like my 200 lines of code and be done. Why do I first of all, why do I do 200 into 500 lines of code? Mm-hmm. And then why do I like share them all around the file system, all of these different files? And I think the reason why maybe she did actually explain it better. I just didn't understand. But my impression now is that maybe she didn't fully was fully able to explain to us what the benefits of this abstraction and indirection and encapsulation is, that she came fresh from university, so maybe she never worked in a code base which has like not 500 but maybe 500,000 lines of code.
Yep.
And I guess like if you have that background, then you can more easily see why that's actually an advantage, and then also tell people why that is an advantage, even though in their specific toy problem it might just seem like pointless boilerplate.
Yeah, but with objects,
Java,
with objects you can if with Java you can explain even without a huge code base, like objects, like cars which have state and they accelerate, or robots which can shoot, So
yeah, we did all of that. Yeah, we did that, but
okay.
still, like do you know the dining philosophers who have like a table?
Yeah.
Right. So we programmed that. So we did program extra stuff with it, but still the question was like, but why do I have several files, and why do I have like a field and then a getter and a set? Why don't I just have like a data structure as a Turbo Pascal and then write my 200 line long as method or procedure and be done with it, right?
But actually what I remember is I started with C++ and then came Java, and I had similar questions because in C++ I really liked the header files. They were separated from the implementation. And in Java I had to write the files everywhere, and I didn't like it at the beginning. So that lots of files, this is crazy. And the problem was as well that I had Windows back then. And, the packages back then, not everything was lowercase, so Windows couldn't find, the files, so it was crazy at the beginning. So, but by the way, regarding your Turbo Pascal experience, did you actually, do you know that in Java there is it's called, I look it up, Robot Karl. And this is very similar to what you explained in Turbo Pascal, but it's in Java right now. And then actually by accident, I started this once. And this is so small, small creature. And you write Java code, it gets compiled and executed. And this is actually very similar to what you explained in Turbo Pascal.
Yeah, I think there's also an international version of this Turbo Pascal thing. But
we're speaking of Java. You are a Java advocate and not Turbo Pascal advocate. So
Yeah, no. I mean, I was trying to say that I think this is pretty common, because I think it's an interesting way to teach people this situation, because it's simple, right? It's very simplified. So you have like an environment in which you don't have to face like an API, or actually it is an API kind of, but you don't have to face like all the complexity. It's just like, okay, learn a couple of control structures and call these methods or procedures or whatever and be done with it. But the thing is that afterwards then, so Java, afterwards I went to university. I studied math and computer science as a minor.
Hey, how hard was it studying math?
Too hard. That's I can say. It was too hard. Actually, it was. I'm not sure. Like I have trouble sitting down and working on my own on some huge project. Like, for example, sitting down and working and like learning for 6 to 8 weeks for for the exams.
Okay.
So what I would usually do, I would reserve 6 weeks of my time to test to learn for the day, and then I would not learn, not study. I would feel really horrible about it too. So I didn't enjoy myself, right? I was like, I would get up in the morning and I knew I would have to study, but then I didn't. And then I kind of felt bad about it. I was stressed out. So I did nothing productive the entire day. So I was stressed out. It wasn't like that from the first day of university, but at some point it started to become like that. And so after the first 2 years, I mean, now we have bachelors and masters, and bachelors after like 3 years, I think, and masters after 5. In Germany back then, you had like the diploma after whatever 5 years or however long it took. And you had like an intermediate diploma, which is not an official certification. It's just like something like an intermediate step. And after 2 years, I realized, shit, I can't keep going like this. The math stuff is just too much and too hard. Like you can't just, like my grades weren't that bad. I used to just like learn everything in the last couple of days. Mm-hmm. But if you learn in a rush like that, you forget everything. And then every future exam becomes harder. Like I was building on sand, right? I was learning so late and so rushed that then the next exam would just be so much harder. And I realized like I can't keep going like this. I already had computer science as a minor, and I realized, you know what? Like there's like this theoretical computer science. That's fun too. So I switched. I did theoretical computer science as a major then.
Okay.
And I wrote, what my diploma thesis was about temporal logic.
Wow.
A language over temporal logic strings. So basically, what you can do with that is you can write formal proofs that your what's it called? The thing that makes your heart beat if you have a pacer, right?
Okay.
For example, the operating system for your pacer cannot crash. Like if it's a limited environment and you can model all the states then you can use this to formally prove certain properties.
Oh, okay. This is like the famous, Laporte, right? Is the guy who also does right now the formal proving that the programs are correct, right? There is a specific language for that right now.
That's entirely possible. I'm not sure, but so that could be maybe even related. So I was very heavy in theoretical computer science, graduated in that, and then realized, oh boy, this is the same problem all over. Like my diploma thesis took me, like it took everything out of me. I realized, shit, I'm not gonna stay at university. I'm just not cut out for that kind of work.
Mm-hmm.
What can I do then? Study computer science. What the hell can I do with it? Well, I did a little bit of this programming, and now that I think of it, it was fun. So, apparently I have to become a programmer now. Oh, great. That's going to suck. Well, but what else can I do? And then it turns out that programming is the perfect fit for my problem. Because programming is exactly the other way around. You sit down, you have a problem, and after 30 minutes, you have a solution and a fix. You're like, oh, wow, hey, this worked. So cool.
Mm-hmm.
And you're in this endless loop
mm-hmm.
of a challenge and then frustration and search, and then a solution and that feeling of accomplishment, and then you go on and you keep doing it. And it took me a couple weeks, and I was hooked, and I had so much fun writing code. And I did a little bit of it during university. That's why I learned Java a bit better. So that's why I started coding in Java. It's really coincidental. If university would have taught me Python or JavaScript or C++, that's what I would have been now, because the only reason why it ended up being Java really is that the university taught me Java. So when I apply for jobs, that's probably because I actually applied for a company that used Visual Basic Net.
Okay.
And they didn't want me because I didn't have any experience with it.
Yeah.
So that's why I ended up with Java. And it was that was great luck. I gotta say, I really feel like I lucked out. I think other ecosystems would have been fine as well, but I feel so at home in this ecosystem, in this community, and with the technology that I really feel I was undeservedly lucky, because it was really university wasn't that bad, right? I don't want to make it sound too bad, but I finished it, but I took very little out of it. In the end, I was like, I'm not going to do that. That's the only thing I really learned. That's not what I'm going to do.
Okay. How good were you with differential equations? So in math, you enjoyed that or not?
Well, if you study math, then then solving anything is not really a thing that you have to do. That's what engineers do. They solve problems.
Yeah.
So that's more like, okay, we showed you how in theory these systems can be solved. Now let's move on. So I had only very little contact with differential equations.
Because there are no multiple levels. I was actually curious, how far you got with the differential equations. So, but what you learned then? So if you don't learn them, what was the craziest thing you had to? Do you remember what you had to learn in math?
In math,
mm-hmm.
What was the craziest thing I learned in math? Well, I have to say though, I did enjoy the topic in general, just not sitting down and studying it specifically.
Mm-hmm.
I really liked that way of structuring thought. So when I wrote my book about the module system, I tried to write it in a certain sense similar to how I learned math, which is when you study math, specifically the first couple of semesters, and you have the script that back then, for no discernible reason, the professor would just go up to the chalkboard and just write basically his script by hand on the screaming chalkboard. Every one of us struggling to understand, because at the same time we just have to copy the text.
Yeah.
And in hindsight, what kind of teaching environment is there? Who thinks that's a good idea to teach anybody anything? Mm-hmm. You're basically 80% of your mental capacity is spent just copying text and not making mistakes. And 20% is if you could try and desperately to maybe understand a bit, because otherwise, you have to learn everything at home anyway. So the more you understand now, the better, but you will have to repeat everything. And the same way the professor, he or she is busy, basically just writing stuff on the wall.
Yeah.
And just like a sub process is going through the explanation. So that's really a weird system. But what I like was the structure of the script. You don't have just text. What you have, everything's that's a definition, or it's a proof,
mm-hmm.
or it's a corollary. It's a theory. Every kind of text has a purpose,
mm-hmm.
and that purpose, it's clearly marked. Usually at the beginning, say this is the definition. And then you read that section with a specific mindset. What comes now is not going to show me a new connection. It's just going to define a couple of terms that I need to know. And then later when somebody and then there's an example. And for example, you should be able, that's a pet peeve of mine. I think you should be able to skip examples in a book. I hate it when an example teaches you something new. I want to be able, in theory, to skip all the examples and still have all the facts that I need to know. Mm-hmm. So something that you need to know, any fact, should be presented elsewhere. And so when I wrote the book, I tried to copy that to a degree, that basically each single paragraph, more or less, at least in my mind, had a purpose. And many of them were put in the book, but many said that's too many. You can't have like 5 call-outs on each page. You can't have like definition, whatever, note, example. That's too much. You have to kick most of them out. So that's a bit sad.
Yeah, but it's also easy to write, because you don't have, to think about a story. If you have always the same structure, it is very easy and very fast to write, a book that way.
Well, yeah, I mean, it's still a book, so it's still good to put in some story somewhere, like why we're learning this, all that kind of stuff. But yeah, when it comes to the meat of it, I know that now, at first I tell you what the terms are, and then I, maybe show some connections to how to do something. Oh,
No problem.
Oh, yeah, right. So you still have to tell some story somewhere, right? Mm-hmm. To make the book more enjoyable and motivate stuff. That's the thing that math scripts are sorely lacking. Nobody tells you why you want to learn this. They assume, well, you're here, right? So that's enough motivation for you. Yeah. Let's just do stuff. And I tend to fall into that trap as well. And I'm actually working on that. I try to think harder about how can I present things about Java to the people who watch or read or listen, without assuming that they're already interested. Because that's my mindset. When I read the stuff online about Java, I'm like, I want to learn. Let's find somebody who explains it to me who already wants to learn. Mm-hmm. But when you make YouTube videos, and I think that's the most medium that puts the most highlight on this, most stress on this, is people are casually watching YouTube. Mm-hmm. They might in general be interested in Java. Otherwise, why would they follow me or the Java YouTube channel? But maybe not in that instance. Maybe it's Friday afternoon. They're on the couch, with a beer. Maybe they just have like 10 minutes before they have to run out. Mm-hmm. So then actually, yes, they're interested in general, but still, why would they be interested to spend time, which is always valuable because, as we said earlier, it's not endless anymore. Why do we want to spend time on this now? Mm-hmm. And I think I want to really get better to not assume that everybody's already interested. Mm-hmm. But that's what most curricula do, right? In math specifically. They're like, okay, you apparently you're interested, which sometimes you're not. Yeah. So let me just tell you stuff. And so in the book, you have to put in more like, okay, why are we learning this? What's the benefit on this? But when it comes to the meat of it, it's really like the structure. Here's a couple of new terms. Now let me show you how to do something with that. And then comes an example. And as I said earlier, I really try to separate these parts and to always know what kind of paragraph I'm writing right now. And specifically the one about not strewing facts all over, specifically in the middle of examples. Like, oh, by the way, in this example, we see that there is a flag called all unnamed for at opens on the module system, right? Like that should not belong to an example that, oh, by the way, that's also a thing that I explained to you now. That should be explained elsewhere, and the example should use it. So yeah.
Just focused, okay? Question regarding math again. So if you see if you see a math or formula, this interests me as a programmer. As a mathematician, can you immediately read it like a Java code, or what they do? They try, to find examples. So what I have in mind, crazy math formula. Some formulas look for me or work almost like a for loop. You know what I mean? Like sum or something.
Sum. Right,
yeah,
exactly,
yeah. And if you look at that as a mathematician, you know what happens, or you know immediately how the diagram looks like, or curve or something like this.
So first of all, so I don't get yelled at by actual mathematicians. My final diploma says I majored in computer science and math was my minor, so I wouldn't call myself a mathematician.
No, but still.
But yeah, so that's a good question actually. I think there's a certain relation to or connection to programming languages and syntax specifically.
Yeah.
That. It's a yes and no answer. Like some stuff I learned, right? Like, for example, sums, obviously, and, these products, and probably more that I forgot. And then also like matrices and eigenvectors and what all of those notations mean. But it's really very much a language that you need to learn. So there's just, there will always, for every mathematician, there will always be formulas, I think, that they will not immediately understand just because they may not be steeped in that specific subfield of math's nomenclature. Everybody uses their own shortcuts. I mean, of course, the sum symbol, everybody uses that. But what means uppercase phi or phi is what is in English. In Germany, we say phi, this Greek letter, right? For, just as an example.
Yeah, let's say phi. Phi sounds great, so keep.
Let's say phi, yeah. So what does that mean in this? I'm just saying, I'm just making this up, right? Maybe phi has like a specific meaning that's always the case in everywhere, like the sum symbol. But there are certainly symbols that I learned that only apply within a certain subsection of math. And so if you know that, then you can read the formula. But if you don't, then you can't.
But you can look it up quickly, right? So I mean, there's no problem.
Yeah.
It's like,
Yeah, that's actually not that easy. And the reason for that is that mathematicians are horrible at naming stuff. I mean, again, they write with chalk on a chalkboard. So obviously they're not going to give anything a good name, right? So it's always single letters. What are you going to search for?
Oh, this
like
is like
math, phi?
This is like Scala, something like this, right? So.
Maybe, yeah. It's like take your program and then like shorten every variable to a single letter.
Oh, yeah. Okay. But because what I thought about is if two mathematicians talk about a formula, they would be able to refactor it as well, right?
Yeah, I mean, like in the end, when you solve an equation, it is just refactoring.
Yeah, you're right. You're right.
Because
solving equation is a refactoring. Absolutely.
Then you're trying to get in the end it says like x equals 5, and it's like, yes, then you're done, right? But in the beginning it's more complicated, and you're not allowed, that's the whole point, right? To change the correctness or the properties of the equation. Otherwise, it would change the result.
The problem in Java, we have already the x equals 5. There is no need, to be more complicated than this.
Yeah.
Perfect. So after the university, what I understood, you didn't enjoy math that much. But what about the theoretical computer science you learned? Was it something useful? You enjoyed it better than math, or what was the story there?
Yeah, so again, like I did complexity theory. That was surely interesting. We did some weird ass stuff. Like there are sublinear algorithms for a lot of interesting things. Like for example, determining, say you have an image and you want to determine whether the shape on the image is convex or concave.
Okay.
Obviously, you can look at all the pixels and decide. But there are sublinear algorithms for stuff like that. So they work in logarithmic time, which means if you double the size of the image, the runtime of the algorithm barely increases at all. Of course, it's not 100% perfect, right? Yeah. You have to then, because it can't be. So then you have to have error bounds. And so we had in one class, we discussed this and showed proof. It's not just discussing this, right? It's like, okay, so this is the algorithm. What are the properties? What can we say about correctness? So we want to have guarantees, which is, if the image is convex, then it will be recognized in so many % of the cases, or it has to have these properties to be recognized. Sometimes the runtime is guaranteed to be logarithmic. Sometimes it's just expected to be, meaning the algorithm may, when it finds unexpected data points, parse more and more of the image until maybe it did in the end take in the entire image. But then in most cases, you will still have a good runtime, but just some bad cases, you'll have a longer runtime, which is the case, for example, like with sorting algorithms, right? Many sorting algorithms actually have, like a good sorting algorithm, if you give it an almost sorted array, it will be done very quickly.
Yeah.
And a bad sorting algorithm won't. Like it's a bad algorithm, it will just still do all the same things as if the array is totally random. So stuff like that, right? So you have certain properties. There are streamable algorithms, which means what if each bit just comes by once? Like you can't go back. You just have to keep reading future bits, but you can't go back and repass bits.
This is actually useful, right? This is useful for GMS.
It is.
Yeah.
So I didn't know back then, of course, right?
No.
Like it's okay. We would try figuring out why stuff on images is convex. Great. Why? No, it doesn't matter. We're doing it now.
Okay, but you enjoy that, or?
Yeah, kind of. Like that's the problem, right? So I think generally I did enjoy these, even math. I did enjoy the exploring those ideas, and my problem was really more like the learning part, because you have to.
Yeah.
Like I gotta say, compared to that Java is easy in the sense that you can, and it's not just Java. Like I think like programming in general is easy in the sense that you can get really good results without having to sit down and study hard for like days or weeks on end.
Yeah.
Of course it helps. Like I'm not going to say like if you read a book about data structures or about design patterns that it's not useful. It's definitely very useful. But if you don't do that, even if you don't do that ever, you can still be halfway competent. Whereas when you don't do the math or computer science, like in university, in these like theoretical environments, if you don't sit down and try to learn the proof, until you can not only like know it, but you can reproduce it. And you can even apply the way that the proof worked to future problems, because that's what you're being educated towards, right? Mm-hmm. The goal of this is that you can develop these algorithms on your own and then can prove these properties about them. But if you have like big data, so you have like huge graphs and you want to find out certain, whether there are certain, connected subgraphs in some way, right? That you want to like, if you have, or a graph has certain properties, if you want to write a solution to that, it's great to write something. But if you want to be an established, computer science researcher, or like even a competent team lead, or, somebody with a PhD in one of these companies, you then want to sit down and be able to prove that, yes, this works. Mm-hmm. And in which cases does it not work? Which properties must the graph have to fulfill these, fulfill the requirements? That's, I think, something that you're being educated towards. And that was I was struggling with, because then you have to sit down and you have to come home and, study this shit for like 4 more hours. Mm-hmm. And I took the time. I just didn't do it. I'm really, really good at, procrastinating and pushing out work.
Yeah.
And so that's like, it's totally my fault. So it was not a problem of the material. It was not the problem of me being too stupid or me not being interested. It was just, I just have this problem with, sitting down like that and working on something which seems so, I think I didn't get enough joy out of fixing these intermediate problems, like understanding these single steps, right? Mm-hmm. When I did do the work and when I was done with it a couple of hours, I was like, okay, great. I did it. Great. But I never had this endorphin rush, which I get with programming, which I still get today. I stream live, right? About once a week. And still that you can see this on stream sometimes. And we're like, okay, let's try whether this works. And like 2 hours later, I'm like, yeah, it works. That's so great. Wow. That is so cool. Like, I'm really enthusiastic about having achieved the goal that I set out to achieve with programming. And I think that was just lacking.
This was the streaming for the casual viewer, what you said, at 5 minutes time, on Friday.
Yeah.
This was especially for him, right? So like, regarding, you said with the images, during my study, so I was already loaded with stuff, but there was one, optional or additional classes. I said, okay, I can do this because sounds fun. There's nothing to do. And this was called multimedia. So I thought, we will draw some pictures or, look at JPEGs. And this was like crazy, compressions algorithms and how JPEGs is compressed on everything. This was pretty hard for additional classes. So since then, I'm really not so fascinated by multimedia. Yeah. What I have to do, you have to drink your tea, because what makes me crazy, there was the formal description, and there was one famous guy, but I don't think his name was Laporte. There was a different name, but I will have to look it up. Otherwise, I would just think about this, and I would just cut it out later. But I will have to find it. This is okay. You can.
So there is, yeah, sure. But there's also a guy called Hoare, Hoare, and he wrote but that's sort of programming language. It's like a formal language that can be used.
Yeah, but this was very famous. I think the language was STL or something like this. Not STL. It was a formal language which is used right now. TLA plus, and the guy is
temporal logic of actions. Yeah, that should be close to what I was writing my thesis in. I mean, it's a huge field, but yeah.
Back to the show. I found the answer. It's not Laporte, it is Lamport, Lamport, and this is Leslie, and the language is TLA+. Now I focus on the show again. I just thought about, the formal verification about the language, and now I have it. I will put it to the show notes. It is Leslie Lamport and TLA+, and this has to be related with your work at the university, I think.
Yeah, like I have the Wikipedia article open right now. By the way, first appeared 1999, but yeah. Sometimes.
He copied you. That's the problem.
It said implementation language Java.
Yeah, this is why I thought immediately about that. And
oh, nice. Oh, so it's under the hood. It's Java, because it seems to be like more. It says it's a testable pseudo, like writing pseudocode. So yeah. So what I would do is. So in Wikipedia it says as well. So the language has a certain a couple of definitions. Like it has something. It's a state. It has you can define behavior, a step, a stuttering step, whatever that is. Relations, state function, state predicate, invariants, temporal formulas, and they do this in a kind of a pseudocode as it looks. And what we would do is just use formulas for that, right? Like you would say for all states in which the condition XYZ holds, there's never a state reachable for which the condition, X, Y, Z prime holds. So the point of that is then you can prove that whenever the system successfully booted, for example, it can never crash. And in general, these things are not provable. That's the undecidability problem. But you can limit the space that you're describing. If you can limit the space that you're describing, then you can. And that is, as I said, that's very interesting when it comes to certain pieces of very simple, because at the moment, these systems have to be almost laughably simple to be able to prove anything about them. Also in realistic time, because this takes forever. Because what you're basically kind of almost doing is building the entire state space of the system and then verifying that certain formulas hold. But I found that very interesting. But once again, I find it interesting to be like, I would watch like a course on that would give me the high level summary of what's happening in the field, like, once a week, or like a YouTube series. I would be totally into that. But not to the point where I spent like 20 hours a week during regular coursework and then like 40 hours a week during when writing my thesis.
But in the Wikipedia article, it also states temporal logic. So it was absolutely area. And by the way, Amazon S3 used TLA Plus to verify the log behavior inside the storage layer. So it's actually and this is why I remember the guy. But interesting. So,
definitely.
But now we clarified that, so this is nice. So you have to look at this because it's in Java.
Yeah,
I mean, you are Java passionate, with your background with temporal logic. Maybe you could do something great, some very small open source project or whatever. Just play with it, because I think this is now you are the perfect guy, passionate about Java, and you have some background knowledge with temporal logic.
That's like, I would never expected these two things to come together. That's so amazing.
Yeah, you see, perfect storm.
That was a great, it was. But also still, it's just, in quotes, implemented on, you know what I can do? We can search if it's an open source. Is it open source? It's at least MIT licensed. Yeah. If we can find the sources, we can just update them to Java 17, right? Yay!
Yeah, of course. That's the biggest commit, Well, I will introduce everywhere multi-line strings. This is my contribution, without breaking anything. So.
Yeah, true. I mean, and then the other thing is, since the performance should play some role here, for example, when Valhalla rolls around, for example.
Yeah, Valhalla is too much. Wait a second until we reach Valhalla, because what interests me after university, you knew a little bit Java, but you didn't learn Java at the university, right? You learned at the high school, what I understood.
Yeah, so we did a little bit of Java in high school.
Yeah.
That's why I actually learned it in the sense, or rather, that's why I got taught. Like, okay, so this is how fields work. This is how, how these programming structures work.
Yeah.
So that's why I was taught how Java works.
Yeah.
And then at university, it would be used in different courses. We had some long, actually the greatest things that, when it comes to working as a software developer, the greatest things I learned in university were not in the courses, but in these, or rather actually, technically were also courses, but not like sit down and listen courses, but, these group projects.
Yeah.
We had one, I think like in 4th or 5th semester or whatever, where it was, I think like 4 people, we were implement games, and we would like spend a couple of weeks on that. And that was like, that's so ridiculous. Already my teacher in high school, she taught me about, the waterfall model.
Okay.
And then at university, we actually like literally had to do it by that, right? So they were really they were taking us by the hand through the entire, do the design now, do this now, do that now, which is such a bad joke. Not only is waterfall, okay, let's not even talk about that. I just assume that your listeners know why that's maybe not the greatest idea, but just who would take a bunch of students who have never worked on any meaningful software project and then say okay, now you design a system up front.
Yeah, but this is normal, I would say, right? This is what you can expect. I mean, this is.
Yeah, but how can you even if you think waterfall works, it obviously only works if you have experienced people there who know what's coming. How can you do that to students who obviously don't know what's coming because they've never worked in a team on a project like that?
But waterfall never worked. I was in a waterfall project, with UML and everything, and this project which worked, where we ignored the entire thing and we did our thing, and then we said, okay, now we have the documents, and we generated the documents from the source code afterwards and did tricks.
Yeah, I think of course.
It never works. It can never work. A waterfall, it will never work, except, you are building hardware or spaceship, and you have to use your diploma or whatever you did, to prove that the program is correct. So there is a more or less waterfallish project, because you have to know a little bit in advance, the hardware, the specification, the costs. So it's impossible to be highly agile if hardware is involved. But in a software project, waterfall is almost mission impossible. And by the way, what I always say is, not only software, if you think about playing music, doing sports, or whatever or learning something, it is never waterfall. It's not like in sport you're planning, I run a marathon, so I will run the first 5 minutes, this speed, and then it's okay, it will never work this way, right? You have to adapt, and this is, I don't know who came up with the idea that waterfall can work in something like software, because software is the only thing which you can change all the time. In hardware, no problem. Even in construction, waterfall doesn't work well, because they always adapt to to changes.
Yeah, so there's several things there. So yes, first of all, software is probably uniquely well suited to something like Agile, because you can so easily go back. And even if your customers already use it nowadays, you still just change it, under them.
Yeah.
There's some automatic updater running. They won't even notice if you don't screw up. So exactly. So software is obviously best suited to other approaches.
And I really hate the word agile, because it is like it is. You cannot do waterfall, and agile is normal. So, stop, because there's nothing to sell there. You have to just, make your software as quickly testable as possible. So, the time to first run should be as short as possible. And if you're constantly running the software, you are somehow agile, right? So this would be my definition, because you're constantly testing the software. Yes, and you can use JUnit or whatever you have, but make your software runnable as quickly as possible, right? This would be my agile definition.
Yeah, and as you say, many things in life work like that as well. But you have to say that many things also work like waterfall-ish. So first, as you said already, engineering, anything that involves hardware, right? So that includes obviously like building bridges and skyscrapers and stuff. And yeah, I think like there are the reason why they, I think, are often, especially nowadays, are overrunning budgets. I think it's not so much the planning process. I think it's more like the monetary and social incentives you build around that. Yeah. Right. So if you want to build, if a city wants to build an airport like the one that's behind you, I think, and also the one that like Berlin has famously built an airport for.
Yeah, it was very agile, yeah.
Yeah, and I built it, I don't know how long they exactly built it, but I felt like for 10 years they were going to be ready next year.
Yeah.
That was like a running joke. But they do have, I recently checked, they do have flights now. So they are, at some point, they apparently opened, at least partially.
At the point is, Corona time, they opened.
Amazing. Like, that's great timing.
Yeah.
So yeah, but the thing there is, the incentive is, of course, the city wants to build it, or, the country, whatever. They want to build a project. Even private companies, they want to build a project. Of course, they have to pick the lowest bidder.
Yeah.
And so there's an incentive for everybody to bid low and be very like, okay, like everything you want to change. You want to change the color of the signs. That costs like $1 million more.
Yeah, exactly.
Because they make their money over change requests.
Exactly.
And that's not, I mean, once again, still waterfall, probably not the best approach to many things. But that comes then on top, right? That then you're stuck in a waterfall system where you have an incentive to bid low and then to overcharge with changes, which immediately creates this conflict between the offer and the design that was agreed upon in the past and what the customer actually wants. From day one, you're basically, as a software development company and as a customer, on opposing sides of this.
Yeah.
Immediately, you're like as soon as the project, I mean, if you worked in companies with, with these kind of procedures, and you know how that is, right? Yeah. Once the company comes into like the 80-90% margin of the agreed upon budget, they want to get done. Like they just want to get this project done because they still want to make money. Mm-hmm. And at the same time, the customer is like, I have to find every single comma that's wrong, because if I don't and they give me the software, then I have to pay them big money to afterwards, right? As a software.
Yeah, this is a big software project. Are exactly the same. So I would say, yeah.
Yeah, exactly. So, but once again, I think certain stuff just has to be waterfall, and then I think waterfall. I think the doesn't work part is like there's a spread there, right? It depends on the experience, and if you did a project a bunch of times, similar things, and you have to offer it again, still many companies at least have to have some kind of estimation and pre-design phase, because that's how customers still often work, right? Like specifically if you work for at least in Germany, I'm pretty sure it's in other countries the same thing, for any kind of official, like a federal agency or something. They can't, even if they would want to, they just can't be like, okay, let's just do a contract. We estimate this costs $500,000. Let's just see where we went up. Let's be all agile. They can't. Like, they're not allowed. They have to do exactly the thing where you give them an offer. That's what it's going to be. That's what's agreed upon. And so I think it's still the reality for many companies. And, they make it work at least to a degree. So I think let's say the amount of times it fails and the degree by which it fails, that varies a lot across companies.
Yeah.
And that depends, I would say, largely. Well, to a degree, it depends on processes that are put in place, but also it just depends on the expertise of the people involved.
And fun.
And that's why I thought
fun of the people. Expertise is one thing, but if you really like what you are doing, it will work. Because as you said, Java is not like rocket science. You don't need, big experts. You need someone who would really like to do something, and then it just happens, I would say. Small motivated teams. This is the I would say.
And that's something that we were actually at university. So waterfall process aside, which we had to draw like diagrams, and I wouldn't say we hated this, but we thought like this is just pointless work. Why?
Yeah.
But then again, you're at university, you're in school, you do pointless work all the time, so we didn't question it too much.
Exactly. This was
But then when the actual implementation started, I had really a lot of fun. And the weird thing about this is I did not realize until university is over that was the fun part of studying computer science. That actually I did enjoy that. Like while I was doing it, I was like, well, I'm a theoretical computer scientist, I just do this menial programming a bit on the side. I didn't notice that I enjoyed it a lot. And that I would sit down at times when I had to work on this project, but I also had to study for an upcoming exam. I would often distract myself from learning for the exam by working on that project because, well, that's also university work, right? So it's kind of not procrastinating. Yeah. And I would do a bunch of stuff there, and I learned about issue tracking, subversion, and then just by being exposed to it, I learned a lot about just Java, right? I still remember that was so great. I remember, so there was always a professor with us, right? When we would come into the labs and program on site, we'd program at home a lot, but also we would meet twice, I think, a week for like 2 hours each to sit in the lab and program there so somebody could, just help us out with stuff. I remember we were putting stuff into a collection and we didn't find it. We're like, why can't we find this? It's like it has the same thing. It's like, yeah, you have to override equals. And that was the day where I learned about equals. I still remember that, how the professor explained it to me, that this is the method that gets called, and this is what equality is decided upon. So you can't just throw in the same thing. You have to make sure that Java recognizes it's the same thing. Then I learned stuff like that. I think I learned about hash code there as well. Oh yeah, I learned at some point really the difference between Java AWT list and Java util list.
Okay.
Because like in the beginning you program, you're just like, okay, I want to use a list. Why are there two lists? Are they the same? What's going on here? And so I learned to practice that. No, they're not the same. And what's this? So I really like a bunch of the practical things you have to know in those exercises. And I know that university is not there to teach you to become a software developer. But even so, since most computer scientists will end up that way, I think it would be kind of nice to better prepare them for what's out there in the world. Because I really think, like, none of the systems we use again, are rocket science, right? Git isn't, at a low enough level it is. But as a user, it's not easy to learn either. But it's not something that you have to study for a year to get a grips with. You can just sit down and get a course on that, and then you can decently capable of solving everyday problems.
Would be enough to the students, create your own open source project at Git in Java, of course, and play with it and show us the results and create, a small presentation, what you did, how you did it, and what you learned. This would be enough, right?
Yeah, and then all the steps, right? So it's So what I actually
or team projects, even better. View students on one Git project, because then you have the branching and CI/CD. And as a professor, I would say it has to be fully automated CI/CD, fully in place, and this would be enough. But back to you, because
let me stick to that. Sorry, you probably have some timetable in mind. I'm totally going to bust that. But here's the point. I did exactly that. That what you just said, exactly my opinion as well. All of these tools, like what unit testing, build tools, then CI/CD, issue tracker, version control system. If I didn't miss something, that's like the key components that you need beyond the language, that you need to not just be programming. That's why I usually make a distinction. Programming is just writing the code, and software development to me is more like everything around it as well. Separating work, doing reviews, making sure the tests are running, using version control. all of that. And I think these things are not that hard to learn, but when you never got in, or rarely got in touch with them during university or whatever education you had before, and then you have to learn them all on the job, then suddenly it's so much. And on top of that come all the web frameworks, and then, all the AWS services. And so then there's already so much more on top. And I really feel like, I'm not sure how it is nowadays actually, but I think in general, universities could do a better job to make sure that at least these basics are covered. And I did that when I gave a course I gave a course for like a year at university, which is somewhat close by here. I did exactly that. We started with first half year we learned the basics of Kotlin. Sorry.
Okay. This is what ends with KT on this like data class and stuff like that, right?
Yeah, exactly. So we picked that.
By the way, what's your opinion of Kotlin? So I look at it a lot, but I have to say, I don't think I would be far more productive with Kotlin than with Java 17, to be honest. I mean,
productivities. I don't know. I have no idea how to judge productivity. My problem is as soon as something new comes out, my productivity tanks. You know how much time I spent refactoring for loops to streams that were perfectly fine as for loops just because I wanted to figure out how for loops feel how streams feel, and where they work and where they don't. So productivity really, like every time I get something new in my hands, productivity tanks because I'm too busy learning the new thing. So I'm not sure whether I would be more productive in general, even after I learned everything. But I think it's very interesting. Approach that basically, maybe that's too simplified, but Kotlin is basically just kind of like Java++, right?
Yeah, like Groovy was. You remember Groovy?
Yeah, I do. I didn't use it, but yes.
Yeah.
But Groovy went one way, and I would say that Kotlin went the other way, right? Static typing, and they, like, for example, I like what they did with the type system with null. So I think what they did is Java works great the way it does, but some decisions made, in the 90s, in hindsight, which is always 2020, weren't ideal.
No, so I'm with you. I'm with you, Nikolai, because something different. My problem is, you are more on the educational side and I'm more from project side. And if you're running something in projects and you say Java, so this is an obvious decision. So we have JVM, we run Java. But if we say we are no more, you can do whatever you like on the JVM in a project, then, okay, some developers would pick Kotlin, but I guarantee you others will pick Scala, and others will pick, Groovy. And for me, the polyglot programming in a larger project, this is the beginning of the end. But why introducing such, complexity without obvious, benefits? So this is why I asked you about productivity. So I would say my opinion is, just stick with Java 17. And if you don't like Java, then maybe, it's time to move on to Go, Rust, or whatever you have. Ruby was one time, but there's no more Ruby. Maybe Python. So I don't understand, to switch language from Java to something else, the benefits for me have to be huge. Otherwise, it's not worth, to running something similar to Java with the same libraries as Java. So I would say, okay, if it's just 30% different than Java, I'm bored. So then I just stick with Java 17. But if everything is different with like go to Go, Rust, then I say, okay, Rust is even cool because you could transpile to Wasm, or we pick how it's called, Swift from Apple, because not native compilation. So this is, for me, the use case is clear. Complete different ecosystem. Go for it. But I don't get it. I'm in Kotlin, but I get the same Java collection, everything like Java. So I have to know Java. This is not. I would say, it is even beneficial to know Java if you use Kotlin, because the entire Java library is there, and then you have in your Maven there is a Java version, Kotlin version. You have to keep both somehow up to date. So for me, I would. To use Kotlin in a commercial project, for me, the benefits has to be huge. And I don't get it. So, but I had the same, discussions with Jython back then, Groovy, Scala. I think I got to know, why you're still doing Java and not Scala? Why are you doing Java and not Groovy? I got the questions all the time. And everything gone, but Java remained. This is actually the strange part, right? And I have to say, Java 17, right, or Java 16 already, but 17 is LTS. They are getting better and better and leaner and leaner. So it is not as nice as Kotlin. I know fun as function, and this is nicer, but I would say for me, I don't get the reasons in commercial projects.
Yeah, so there were a couple of interesting things you said. So first of all, you said, well, new platform might just offer me capabilities that the JVM just doesn't have.
Yeah.
And that's obviously right. Like if that's something that you either need or want, then sure. Then that would be just, you have to pick that. That said, the Java ecosystem is very powerful in many ways, right? So for example, like the number of mature IDEs, testing frameworks, web servers, web frameworks, all of that. There's like they're from the smallest to the largest projects, from industry standards with multiple implementations. We have so much to choose from, in a good way. So that could, of course, also be a little bit overwhelming, but still you have so much choice of such like build tools. We have like, you can maybe let's include Bazel. We have with Maven, Gradle and Bazel. We have 3 really good build tools, which is some ecosystems have none.
Yeah.
So really, I think like we're in such a fortunate position in the JVM ecosystem, and you can keep most of that to pick a different JVM language. So that's why I would say, okay, if you need a capability of another platform that the JVM just can't offer, then that would be, of course, a reason, maybe not enough, but that could be a reason to then switch. But if you are happy, like if you think, no, I don't need any specific capability, if the JVM is amazing for me, but for one reason or another, I don't think Java is my thing.
And this is the interesting part, in commercial projects, you cannot just say, Java is not my thing. This is like, I gave you an example. If you go to butcher or to carpenter and they say, okay, my chainsaw is not a thing. I would like to have something, with nuclear powered, chainsaw. I mean, it's okay, cool for you, but what problem does it solve? This is what I don't get. And
but you are aware of the fact that there are different producers of chainsaws, and people who use some of them will like some of them use like just this brand because this is like the best brand because it's made in America. I don't know,
exactly. Or trucks or whatever, right? But
but so it's kind of similar in the sense that.
But they can explain why. They say, okay, I'm using this brand because it never failed in the last 20 years, right? Or something like this.
But there's a lot of subjectivity in there. Is what I'm saying, and that can happen to developers as well.
Yeah, but if every developer picks something different, then
So
recently I got code review. 5 developers, 20 microservices, and I think 7 languages. And then I keep asking, and no one liked that. And at the end, we committed on Java because everyone agreed this is the only solution to the problem.
Yeah, so first of all, I don't want to make the point that everybody should switch to other JVM languages, obviously. And
you say that.
No, I didn't. No,
this was the title of the podcast, Nikolai said, everyone switch away from Java.
Oh my God. I'm so going to get fired. No, seriously though. I think that, so first of all, what you described with this polyglot situation, that's of course not ideal to say the least. And I think there's this adage where you say, is it adage? What is it in English? Whatever. Pick the tool, the best tool for the job.
Yeah.
But I think there's a caveat there that doesn't get mentioned a lot. And that's, what if the best tool is just better by not too much of a margin?
Exactly.
But the specific tool will be a different one for each thing. So once again, as I said, you write a project which consists of a bunch of microservices or whatever, different sub-projects. And for each of the sub-projects, some other language has like a tiny, like a 5% or whatever advantage over Java. And then you end up with like 5 languages in that project together. That's not ideal. So that's really not a good situation to be in either. But what I want to say was that what I think is really important to mention is what you already said. Like there were already all these languages that were going to make Java obsolete, right? Yeah. Even languages on the JVM. And most of them are not having, let's at least say they have not a growing market share at this point. And I think that's something that is really hard because Java does have a large development team behind it, like the entire OpenJDK community is pretty large, and it's working on this, not always to everybody's preferred speed, but they are continuously working on this for decades now, and it shows. Languages started out with, okay, we have tabula rasa.
Hey, regardless speed, I'm really impressed with the speed of Java development. No kidding.
Recently, it picked up, yeah.
Yeah, but I mean, it's crazy, and I mean, even the entire Oracle team did always a great job. I mean, this is. I was always amazed, how fast it actually is implemented. And how backward compatible it is. It is not a big deal to implementing features and breaking everything. But it is a great job, I have to say. Mm-hmm.
Yeah, and making these new features look like Java and not like something that was bolted on the side, which is entirely different.
Yeah, exactly. Yeah.
So a new language can always be, okay, we don't have users. We can just fix all the mistakes of the past, start out fresh, and that's what we're going to do. But the problem then is, so they have a head start there, right? So let's say when Kotlin was created or when Scala was created, I'm just going to make up numbers, they're like a 20% productivity head start over Java. I think you cannot calculate or think about it that way, but just, as a thought experiment. Can they then keep the pace? Or will that 20% be can they keep the pace, or will that be shrinking? And I think that's what happens.
But you're right. But in the case of Kotlin, they created Kotlin to have a decent experience on Android, which is perfectly fine. This was great job. This is what I get. This was an old Java, so the Kotlin was a perfect use case for Android. So this is what I perfectly get, And as you already said, right now, let's say Kotlin is ahead of Java because of features you like. But Java will not stand still. In one point of time, Java will keep up. And then maybe Kotlin is not as interesting as it is. And what's also interests me, what happens in one point of time, Google with the Android, they will say, Kotlin is no more a system language. We have our own, language Go or whatever. This can happen. And then whether Kotlin will still be the thing, This is also what would interest me. What happens if the next Android will be no more Kotlin, let's say? Could happen, This would be the interesting observation. What happens with Kotlin then?
Yeah, I mean, to a degree, you always bet on, when you use a language, you always bet on the organization behind that language, whether it's a private company or whether it's like, like the OpenJDK, like a public group. Yeah. I mean, the OpenJDK as a public community is large, but almost all the people working as part of the OpenJDK, or rather as members of the OpenJDK, do so because their employer pays them for it, right? Even though it's a contribution of individuals, if like all the companies would stop paying people on that, of course Java would come to standstill. And that's true for other languages as well. So the question is how resilient, how much do you trust the organization behind that to keep your things running? And what I think is, it depends on the project as well, right? If you're writing a project that you're using for, to track your table tennis results at work, like use the fanciest thing you can find, to try it out, to see what works, and to see how much of an advantage you maybe have over the other languages, and use that as a testing ground. And I think for every new project, it's not just which situation are we now, but what do we think how long the project exists? What's like the timeline that we have in mind here? Is it a couple of years? Is it a decade? Is it two? And then who do you think can support that for that long?
How many people will work on the project? Because what commercial companies are doing, they are hiring one company and they do something. And then another company takes over, and does something, and then another company completes. And if the first company chooses, Kotlin, but the next one would like to have Scala, and the third one Groovy, then you have a hot mess. But if you say, okay, on Java, JVM, there is Java, there's a less discussion because we already committed. This is the very, how to call it, the lowest possible programming language you can get on JVM. And what you mentioned, Kotlin, I would use Kotlin absolutely on Android, and I would love all the features because this is the system language of Android. I wouldn't try, to use Java on Android if there is Kotlin available because this is, the language of the platform.
I didn't keep up. Are they still using they used Java 7.5 or something on Android for the longest time? Is that still the case? What Java version can you actually use on Android?
I don't even. There's not a real Java because of problems, but I know, right, that Android Studio and JetBrains, this is the company, the IntelliJ, the Android Studio uses Kotlin as the official language. So Kotlin became the official language for Android. This is how Kotlin became popular.
Yeah, but Java obviously still works, right? You could still do it in Java.
Yeah, it has to. But I don't know what's the recent version. I don't even know.
Yeah, because that's of course plays a role there, right?
But it's pointless anyway because we could use JavaFX and ship native executables on Android. This would be exactly. So this is what. Okay, forgot about that, but perfect.
So, but what you said earlier about Java basically being the lowest common denominator, I think at any given point in time that may actually be the case. That of all the languages, that's the one that you can most easily agree on. But I also think, as I said earlier, Java's always keeping up. Always moving forward. And the question is, not only can these other languages keep their advantage if they have one, but also what happens if things diverge? Because improving Java means improving the language, but also improving the virtual machine. Mm-hmm. And while things in the virtual machine are usually more general than they are expressed in Java specifically, it's still the case that if Java moves one way and, for example, picks a feature that is similar to what other languages do, but, slightly different, because everybody has their own kind of data classes, there are always subtle differences. Now Java has records. They're, somewhat similar, at least to a degree, but they're not the same. So there are also these little divergences. And I think they also make it in the future. For example, it may be harder to benefit from JVM improvements for other languages if the way that they turn out do not fit the model of the way that other languages picked something, right? Yep. So maybe as a performance improvement for value types. But, and I'm totally making this up, I have no idea, but maybe, Kotlin or Scala's values don't match on that one-to-one, and then you can benefit from that, right?
Yeah.
So, like, for example, OSGI has trouble adopting the module system because the underlying rules are not exactly the same, and they're not the same in the sense like, well, you cannot make one OSGI bundle into one module. That doesn't work because, for example, OSGI allows circular dependencies, I think, or something like that, and module system doesn't. So suddenly in a situation where you now have a very similar feature in two languages, but not necessarily both of them can benefit from JVM improvements. So I think not only will Java always keep improving and potentially catch up and then surpass other languages, there will also be these small divergences where Java can better benefit from JVM improvements and developments over time.
Mm-hmm. What interests me right now, this is a very interesting discussion, but what interests me is, after university, what was your first job?
Yeah, so I'm a bleeding heart lefty. So I was like, okay, I want to do something meaningful with my job. So what can I do? I'm a programmer, so that sounds like, well, I'm going to be one at least. That sounds like technology. You know what? Climate change, that's something that interests me, or rather that bothers me. So I went searching for companies, organizations that work in that space with something related to renewable energies, specifically, that has something to do with programming. So one company I applied at is, I think they're called Lichtblick, if I remember correctly. So that's then Hamburg, northern Germany, where they are developing, oh boy, what's the word? Blockheizkraftwerk. They're developing these things that you can put in your cellar where that burn gas and give you warmth and electricity at the same time.
Great idea.
And they will put that into people's houses and then load balance them, and they're writing the software for that. And that was Visual Basic Net, so that's why they didn't pick me, which is a shame, but also their loss. And where I ended up at was the Fraunhofer Institute here in Karlsruhe. That's the only reason I'm in Karlsruhe. I just applied all over Germany. And what they were doing, they were creating energy models. So when you ever hear that the European Union projects that by 2030, that so many % of electricity could be renewable, or that appliance energy consumption will behave like this in the coming 30 years, or that, for example, demand-side management of load could be introduced and have that and that degree. These are all things that scientists at that institute are working on, and I've supported all of those with software development because they're writing models. They're writing computer models of these different aspects of the energy market and the energy system. And I would help them with that. And that was amazing. Like, I really enjoyed working there. I really enjoyed working on something that has this impact and that is that meaningful.
Was it Java?
But it was Java, yes. Actually, one of them turned out later. One of them was Visual Basic Net because it evolved from an Excel sheet into Visual Basic in Excel was a VB, and then VB6. Okay. The whole code base was such a mess. It started it was from, I think, Excel sheet and then Visual Basic in Excel, and then was transformed automatically, I think, to Visual Basic 6 project, and then later to VBNet. It had all these layers, and then some student was hired to work on that, and he was like, basically, screw this, we're going to re-implement this, because he had a really good idea too. So he developed a system that I then later maintained. So it was a little bit of VBNet, but a little bit of C# for some project as well, but most of it was Java. Okay. And like once I got the hang of it, C# and Java are very similar. And although C# did have a couple of things that Java didn't, and then VBNet and C#, those are also kind of similar. So it was kind of like this family of languages. Like I learned them all at the same time, but I spent most of my time in Java, and that's where I learned the most, and that's where I always felt most at home and most comfortable with.
Okay. And which Java version was it? Was it modern Java already? Java 11, 8?
Yeah, so that's the funny part. I didn't know that there's such a thing as Java versions, really.
Okay.
I've been programming with Java since, as I said, like 2001, so I have no idea which Java version that was, 1.3 or 1.4 probably. And then during my time at university and at work, all the versions up to 1.7 came out.
Mm-hmm.
But I was not so familiar with the languages and the API, and specifically 1.6 and 1.7 weren't such huge changes. I didn't notice. Like, I just didn't realize that Java actually changes. Or I know, I just download JDK 1.7, whatever. I don't know what that means.
Yeah.
I just write code. So, and then I heard like this thing about lambdas. What's lambdas? And Java 8. So I looked into that, and I remember we were on holiday in South Africa in 2013. And I remember that, Gabi, my wife, she was like exploring some town, and I was like, I think she went shopping or something. And I was like, you know what? I got to stay here. I want to try this thing out. So I sat in this kind of nice apartment looking out over probably, what is it down there? Atlantic or Pacific Ocean? It's kind of both, right? No, sorry, it's not Atlantic. It's Atlantic. Sorry, it's not Pacific. It's Atlantic or, well, whatever. Looking out over the water.
Yeah.
But I was mostly looking at my computer trying to understand these arrow thingies because I was reading a blog post about Java 8 lambdas and what they were all about. And so, okay, what's this arrow thing doing? Okay, so a functional interface? That's so interesting. So I spent part of my holiday sitting at my work laptop and experimenting with Java 8 lambdas because I was like thrilled. Oh, that's a cool thing. I didn't know that exists. And then that was the first time that I actually got in touch with the Java feature before it came out. So that's also when I realized that, Java is being worked on and it is being developed. And I read like so many blogs when I started working. I knew nothing, right? I knew a bit of Java and that was it. And everything else I learned, not everything, but most of it, I really learned from reading a lot. I spent each evening like an hour. That's what I should have done in university, by the way. But I didn't have the apparently enough of the motivation. Reading up on stuff like, what build system are and that random blog post, about whatever really, as long as it relates to software development and Java. And yeah, that was when I started to understand more of the ecosystem, the community around it. Until then, it was basically just the language. Mm-hmm. And that's when I better understood the tooling around that and, the whole entire blogosphere, and there are conferences, and there's a project, OpenJDK, that's improving Java. And that's all. I learned all of that, I think, over the course of like 2013, 2014. Mm-hmm. And then I was like, this whole thing is fun. Maybe I can write a blog. And so that's when I started my blog. When was it? Was it 2015?
Okay.
Let me look. I should know probably, but I'm going to look it up. First blog post was, it was end of 2014. That's when I started blogging. And, I started with a little bit like my Java 8 experience. I used Java 8 at work. Basically, the day it came out. As I wrote about optional a bunch, and I looked up stuff on the mailing list to better understand optional, discovered the mailing lists and discovered what a treasure trove of information they are, but also how impossible it is to find anything on them.
Okay.
Like even sometimes I know I read this mail and I still can't find it. Like, it's so horrible. But it's a treasure trove. Like, if any of the listeners can make time to subscribe to like one of the mailing lists and at least skim them, there's such good conversation going on. Not all of them, right? And there's also these JFR reviews going on. But many of the conversations are so good. You can learn so much about these features, and not just how they work, but why are they the way they are? Mm-hmm. Because it turns out when I think about what that feature should look like for an hour, I come up with a vastly inferior solution to when a bunch of people think about this for a few months or even years.
Yeah, sure. What happens then? You stayed at Fraunhofer, or what you did?
At some point I was actually so interested in Java. I want to do more software development. I want to learn more, not just Java, but software development in general. I felt like I could not grow there because I was the only software developer there.
Oh.
Towards the end, it was like they're all scientists, right? For them, it was really kind of cutting edge to hire somebody who cannot, because if you're working at a Fraunhofer Institute, you're not just sitting there getting grant money to waste. You have to actually apply for research projects, and you have to write all of these reports. It's a lot of work that is directly dealing with. Okay, I have to find somebody to finance my research. Mm-hmm. So I don't. To them, I'm just a cost factor, right? Mm-hmm. Nobody's going to pay me money for any research. Mm-hmm. I'm just doing the back office work for them. Mm-hmm. So for them, it was kind of unusual to have that. And while I was there, they built it out. So at the end, when I left, we had, I think, 2.5 I was one of 2.5 software developers, but still I was the most experienced, which is not good because I was not very experienced. So I felt like I want to learn more about how the software development stuff works. So I was looking for a professional software development company, and I found Dizzy here in Karlsruhe, which is also it's a really great company.
What interests me about Fraunhofer, was it like a backend development? So you wrote Java servers or command line?
No, it was it was one. Well, there were different projects, right? But each project individually was one huge app. That was not server, that was not web-based. I'm struggling. I don't want to call it a desktop app because some of them didn't even have an UI. So we wrote one where the model where the researchers would write their model in Java. That's why it was already there as a Java project or in Visual Basic Net. So they would formulate their assumptions and the behavior of the systems and all of that. They would program that out in Java. And I would just help them. I would just be like, okay, so you need to do this. This is how you design this. This is how you can use Java features. Oh, sometimes they needed special infrastructure that I would implement. For example, we had a lock and we wanted to lock the messages to database so that you can then observe them. So over time we actually built, in that sense at the end, it was kind of like a client server thing where you could launch, because the models take a long time to compute. We would create what's called a linear programming problem, and you can solve that with Simplex, I think, is the algorithm, and Cplex is one implementation of that, the C library that solves that. And towards the end, that would take days. Like literally, the model would run like 5 days. Most of that in C. So like 4.5 days was just C library crunching this huge linear program. And then you had a couple hours before and after of Java code that was shuffling the data around, because a linear program is just numbers and additions and multiplications. It's extremely tough to extremely tough, but like taking a real world situation and transforming that into a meaningful linear program, program anyway. And then interpreting the result is not trivial. So a lot of the Java code was basically busy with that.
Funny fact, I worked once with researchers. They knew linear algebra for optimizations. And they wrote a Java software, server-side Java software. And I had to review the software and help them a little bit. And what's turned out, what they wrote was perfect from my point of view, because there was not lots of over-engineering. The entire structure and the Java classes were to the point. So for me, it was like crazy. I mean, you're really experienced Java developers say, no, we have no idea. So they just, whatever they had in mind. So they wrote Java classes with nice names, with, readable methods. And the program worked, without any flaws until now. So it is actually a very important piece of software. And this was my experience recently with linear algebra for optimizations.
Yeah, mine wasn't quite like that. So they really had. I would say I always said, sometimes in jest, sometimes not so friendly. This is imperative programming in Java.
Okay.
So there were classes there with there were even methods with hundreds of lines.
Yeah, but on the server side, it is almost, you have, this is like request scoped, so they have one method for the transaction. So it's not like, it's different. If you're building something which runs all the time as a singleton, you are more object oriented. On the server, you are procedural anyway, because everything is about transaction. So method calls method, and you are done, right? It's different kind of programming, I would say.
But the thing is, so there was also a lot of primitive obsession going on. The problem was that it was really hard to when they would have a problem, it was really hard to understand what the code was intended to do and whether right. So if you have like a couple hundred lines that just read integers from arrays which have great names like, I don't know, values or something, and push them into this linear program, for example. It's really hard. Like, what is this? Like, why don't you have a class that's called,
you're right.
I don't know, power plant, that has some information about a damn power plant?
So my scientists were better. My scientists were definitely better. Okay, so what happens in Dizzy or Dizzly, you said?
Dizzy, it's not Dizzy like the English word of not being quite full capacity. It's DISY, which is funny in English though. They're working on geoinformational systems, GIS. Also, they have a big Java app that does that, and customers of municipalities or federal agencies, like in Germany, for example, but in Bavaria, their hunters have to register each kill.
Okay.
And that has to be publicly available information. So they, for example, use that, right? So hunters enter their data, and then you have a map where you can see where they shot, I don't know, boars.
Okay.
So stuff like that. And that was a lot of fun too. That was a lot of Java as well. And I learned a lot there, and some of my best friends are still working there. And one great thing that I learned there was how a big professional run software system works. Because when I was working at it Easy, I also occasionally had like a small tool to create. I would just pick dependencies, for example. That's one thing that I learned at Dizzy. I would just pick dependencies who have like, okay, I need that class. It's in Guava. Let's just take it. That class already exists. Let's pick that. And I really learned how in a large project, you can't just like pull in dependencies willy-nilly left and right, because there's actually value. And I didn't understand at the first time. I was like, I want to use whatever library. And the architect, as I said, one of the good friends I got there, like, let's not do that. I was like, what? Why? I didn't understand. Like, why would you not just pull in a dependency? And he really taught me, like, dependencies, they're a liability.
Yeah.
If we really need it, sure. But not just because, you want to write this code slightly more functional and you need to try. Sometimes what he did with me was like, let's check the license. If it works, let's just pick the one class. And please, let's not pull in an entire newest dependency tree just for, a single class that you were going to use.
This is a great architect, actually. So this is unusual. What I still fighting, with millions of dependencies in. Yeah.
And like, he's great. As I said, I worked on Java 8 there from day one. I got half of a month of part-time work on updating to Java 9. We were running on Java 9 like 2 months before the release. Everything was working. We spent a lot of time with that. I mostly spent a lot of time with that. But that was great, right? They see the need to be up to date. Mm-hmm. And I always say, look, this is by now it's probably a 20-year-old, maybe even more by now, Java code base. Mm-hmm. Like, it started very early on. Mm-hmm. It's quite large. It has still a large dependency tree. If we made it to Java 9 pre-release, people can update to Java 11 now. I mean, of course, every project is different. Yeah. But I think from monolithic, old, large code base, we're not in the best position to start this update process. Yeah. And we made it work, and we made it work at a time where that often meant like providing pull requests or fiddling with command line options. And nowadays, most problems can be fixed by just updating dependencies, which is not trivial. But, if you can do that in your project, just updating dependencies, mm-hmm. and you're probably already there. You can probably just bump the Java version after and you're done. Not necessarily, but yeah, so I think it got easier. You kids don't know how hard it was back then.
Yeah, actually, so I started, before Maven and before Ant. So everything was in the project of the JBuilder, for instance, right? So this was mission impossible almost, because every project had different structure. So
yeah,
now the entire.
When I was working out at Fraunhofer, Maven already existed, but I didn't know, and nobody else did either. So the way I got dependencies was looking for jars and downloading them.
Okay,
so I basically had like a pre-Maven experience post-Maven.
What happened after Dizzy?
Yeah, at Dizzy I got interested in more like I started writing the blog. That was a lot of fun. I really enjoyed that. And then I started going to conference at Java user groups and then conferences talking about Java. And then that part grew. And I had a lot of fun at Dizzy, and I really liked the people there. But then one thing, and maybe they would make that decision differently now, was they did not support me in those endeavors.
Okay.
So I would have to go to conferences on my own time.
Okay.
Even though I would be speaking there, having their logo on my slides. And that kind of miffed me. I was like, well, I'm doing all this work, and I do it because I enjoy it, but getting some support would be kind of nice.
Yeah.
And I think that was one of the reasons why when I got an offer to work as a SidePoint. Do you know the website SidePoint? SidePoint.com?
Yeah, I heard about it, yeah.
They had a Java channel a couple of years ago. I was the editor. You never heard about it because I sucked at my job, apparently.
Okay.
So, and they offered me, because I was already kind of active in the Java community a little bit, and they asked like, hey, we want to launch a Java channel. Do you want to be the editor? I was like, yeah, I want to do that. And maybe I would not have jumped ship if Dizzy would have been supporting me a little bit better. And I think they're better at that now, because I think they saw that maybe it was a little bit of a mistake. So yeah, but that was the reason why I decided to then become the editor at SidePoint, and then that's basically mean I became self-employed. And from then on, I did a bunch of things. I would help people with their Java migrations. I would teach people about Java, like doing in-house courses. I would still work for Dizzy as a freelancer on some smaller projects. We organized Accenture together. So Dizzy is organizing not my own, our own conference. The last one was actually. What was it, 28th of September, I think, so a couple of days ago.
Nice.
And Dizzy is not only contributing financially, but also with manpower. So actually, it's all woman power that they contribute. So we're like a couple of people working on that. And so they're pushing that as well, the conference. And so, yes, we're still working a lot together. But then I got self-employed, and I was really happy with all of that. And I was like... doing great. I did these trainings that was cool, and I had time to write on blog posts and go to conferences and speak and all of that. And then last year Oracle comes. So other companies already reached out whether I want to, work for them in this or that capacity. I was like, in the end, like, I want to keep writing or publishing or talking or shooting videos or streaming about Java. And that's just what I'm doing now. And then Oracle was like, you know what? You do what you do, but for us. Like, we just pay you to keep doing what you do, but more. And that was really great because there's always this tension between providing the content that I do provide for free, and my blog and my YouTube channel is way too small to monetize any of that. So I always had to earn money elsewhere. As I said, I do in-house trainings, so that's not a bad job at all to do. But there's always this tension between, do I sit down and write a blog post, or do I, try to find somebody to do a training for?
Yeah.
There's always this tension between something that I potentially want to do a bit more, but doesn't pay any bills, or doing the other thing. I would sometimes feel bad. I would give a week-long course at a customer, which is great because it pays well, and that was good. But then I was like, okay, but now I didn't publish any blog posts or, did any of the other stuff. So I was always like caught in that tension between not most, but at least half of the time that I spend is spent on free stuff that I really enjoy a lot, but I also have to balance that with earning income. And so one of the reasons why when Oracle made me an offer to become a Java developer advocate, after some back and forth, because I really was like, I'm really happy with all this self-employment stuff. One of the reasons why I picked it was just that this tension goes away. Now I can do what I like doing. Like talking to you right now, I would have done that anyway, definitely, because it's a lot of fun. But now even it's part of my job. Now I don't have to, when I hang up, be like, oh shit, now I have to do something else because I still need to pay my, my breakfast. Now it's like, well, this is 2 hours of work done. Amazing.
Perfect. When it happened? When you joined Oracle?
So I joined in the middle of February this year. So just like about 8 months ago.
I didn't know that. I think you are longer an Oracle employee.
See? Everybody was like, that's a great fit, because I basically have been doing that work anyway. I've been running around hyping Java for years now.
Yeah.
So that's why it's a good fit, right? I don't have to say anything differently from what I said back then.
Yeah. And I have your book, I think. You wrote a book about JPMS, right?
We're not supposed to call it that, I learned. But yeah.
Okay. Because I have it. It's just, I think, from Wiley. Can it be? Is this like...
No, that's the bad one. That's from Sander Mack and Paul Becker. And
No. This was what I didn't enjoy it at all. I mean, your book. But
you don't have to say that, Adam.
Yeah. And I saw your blog, and I don't know whether we met.
I don't think we did.
We did? You mean?
No, I don't think we did.
And I say, okay, who are you actually? I have to invite you here, to find about you. And it was actually fun. What I really would like to do is to invite you back, because now it gets too long, and then just talk about Java features. What I really excited, Java features, whatever you are doing, Valhalla or whatever you wanted to mention already, and talk about Java 17 or whatever you have. And
there's so many great things, right? The current Java versions, the release cadence, the LTS cadence.
Exactly. And I could invite projects. Once a month if you like, just talk about Java, because but the very first episode was just like that, that I know what to expect from you, and now we can just focus on content, I would say.
So you were just betting me. I mean, if that's all you did, Adam, you don't have to publish this. If it's just you want to talk to me, I'll just
No, I will.
I just talk it up as a loss. I will talk about Java.
Hey, there's one trick. You know why I'm doing this? Because I don't have to prepare. I ask you whatever I would like to know, and then we have the first episode, and the next one is about content. Nice hack.
Okay, so yeah, exactly. It's a nice air hack. Nice. So you're gonna You're gonna prepare then for the next one? You're gonna be better prepared, Adam?
Yeah, I mean, you are the expert. In worst case, I will ask you questions. No problem. So where
Then
people
I have to prepare.
Yeah, where people can find you on the internet, your blog and your Twitter and your Oracle link, whatever you like.
I don't think there's an Oracle link. If there is, I don't know.
Okay.
So I'm NipaFX everywhere. My website is nipafx.dev. I'm NipaFX on Twitter. I'm NipaFX on YouTube, on GitHub, on Twitch. I stream about once a week. I'm going for a 2-week hiking trip starting tomorrow.
Mm-hmm.
But continuing end of October, I usually stream every Thursday evening in Central Europe. So that's usually like 7 p.m. my time.
7 p.m. Twitch every
for
other
example.
week. Uh-huh.
About every week, but
About
now I'm taking a break. But if you go to nipafx.dev, at the top you will find a link in one of the menus. You'll find a link to a schedule that's always up to date. I go to a bunch of conferences. Yeah, I think those were all the things. If I don't.
And what are the topics usually you like to talk about? Mostly Java.
Yeah, so really what I started doing basically since Java 8 came around, I started being interested in what's new, what new stuff is coming.
Okay.
Because the advantage of that is that you don't actually have to know anything, because nobody knows anything, right? If I want to tell people how to write, for example, to design good desktop applications or microservices or high performance applications with Java, you actually have to have done that for a couple of years.
Mm-hmm.
You can't just come in and be like, well, I read 2 blog posts about microservices. Let me well, I think some people do that, but technically you shouldn't.
Yeah.
And the good thing about new features is nobody knows them. Nobody has 2 years experience with text blocks. Well, maybe now they do, but not back then when they came out. So that's why it's actually quite easy. What I do is I read the jabs, I read the mailing lists. Now I get to actually occasionally ask the people working on that as well, what are your intentions behind that? What were your goals? Why is the feature shaped like this or that? And then basically I report back, because that's something I'm interested in. Not only what is the new feature, what can you do with it, but I also, the more I work on this, the more I realize a very interesting story is usually hidden in why is it the way it is? And maybe why wasn't it like that before? For example, remember up until Java 9, in Java 9 it changed.
Hey, Nikolai, we have to do it the next time. Otherwise, we will speak for 2 hours. But you know what I will do? I will move closer to the mail server, OpenJDK mail server. I will receive, the emails a few milliseconds earlier than you, what, the brokers are doing. And then I will be more up to date than you. Then we can have a fight in the next podcast. Okay, thank you a lot. And I will invite you back this year in one point of time. We will find a date for sure.
Yeah, cool. That would be great. Thank you.
Bye.
Bye.